Hello, I'm Papia. In this problem, we have the function y equals cube root of x plus 2 inside the interval from 1 to 8. We had to first set up and then evaluate the definite integral that will give us the area of the surface generated by revolving this curve about y-axis. So let us recall first how to get the area of the surface. So recall surface area is given by 2 pi integral from a to b r of x, and I'll tell you what this r of x is, times square root of 1 plus the derivative of the function square dx. So this is the setup. We have to figure out a, b, r, and the derivative of the function and then square it. Then we'll have the integral that we need to evaluate. Okay, to understand this r of x, let's graph the function first. Note that it's a cube root of x plus 2, and you are only graphing between 1 and 8. So when you plug in x equals 1, you get 1 plus 2, you start at 3, so somewhere up here, say, and at 8, when you plug in 8, cube root of 8 is 2, 2 plus 2 is 4, so it'll end at 4. So it looks something like this. Okay, so this is the portion of the curve we're considering. Look at the question one more time. You are revolving the curve about y-axis. So you take this curve and you're revolving about y-axis. Then the surface that it generates, we're trying to find the area of that surface. Okay, so in this setup, of course, a and b are the limits of this interval. R of x is this distance, the distance from the axis of revolution to the curve. That is r of x. Now let's think about it. In this setup, what is this distance? It can be anywhere on this curve, right? Well, look, this is just the x distance. It's been measured from the y-axis to the curve. So r of x is nothing but x. Okay, so let's come back here and let's start setting this up. We know the lower limit, it's 1. We know the upper limit is 8. We know r of x is x. Okay, now inside the square root, we have 1 plus the second term is what we have to figure out also. Okay, so we have to find the function. Let's come back here. What is our function? Function is cube root of x plus 2. Or you can rewrite as x to the power 1/3 plus 2. Now we have to take the derivative of this function. Okay, so the first derivative is, just use the power rule, 1/3 x to the power 1/3 minus 1, so negative 2/3. And the 2 just goes away because the derivative is 0. If you want, rewrite it as, see, x has a negative exponent, so bring it in the denominator and make the exponent positive. So 1/3 times x to the 2/3. Okay, so this is the expression that we will put inside the integral and square it. So you will have 1/3 times x to the 2/3 square, then dx. Since we have to evaluate this integral, let us actually square this expression. So one more step, 2 pi integral 1 to 8 x square root 1 plus 1 over, so you're squaring 3, you get 9, and x to the 2/3 square is x to the power 4/3 dx. So this is the definite integral that we can use to figure out the surface area when you are revolving this curve about y-axis. Now, let me erase the board and then we will solve this integral and actually find the surface area. Recall that this definite integral is what we will use to find the surface area, and it's 2 pi integral from 1 to 8 x square root 1 plus 1 over 9 x to the 4/3 dx. So now we have to evaluate the integral. In order to do that, let us just evaluate the indefinite integral and find the antiderivative, and then we'll come back here and plug in the limits to that antiderivative. Okay, so let's just consider the indefinite integral x times square root 1 plus 1 over 9x to the 4/3 dx. So notice that there's a square root function inside the integral. So let's see if a simple u substitution works or not. Okay, so let us simplify this expression a little bit more. Let us add the two terms together inside the square root. Then we will have a common denominator of 9x to the power 4/3. And then in the numerator, you're just going to cross multiply. So 9x to the 4/3 times 1 plus 1. All right, next step, you have x outside. Inside the square root, keep the numerator terms as it is, 9x to the 4/3 plus 1. Now the denominator is also a square root of this entire expression, 9x to the 4/3. And see, if you take square root of 9, you get 3, and if you take square root of the next term, you also get some simplified form. So the numerator remains as it is, and the denominator becomes square root of 9 is 3, and x to the 4/3 to the 1/2, that's x to the power 2/3. You can pull out the 1/3 because it's just a constant, and then you can combine the x in the numerator with the x to the 2/3 in the denominator. You know they have the same base, x, so you just subtract the exponent. So you will have x to the power 1 minus 2/3. And then we'll still have the square root. And don't forget to write the dx. Okay, one more step here. So x has a power of 1 minus 2/3, so 3 minus 2, that's 1/3. And then square root 9x to the 4/3 plus 1 dx. Okay, now we have a nice form, and let's see if u substitution works. Now what will u be? Well, obviously the portion that's inside the square root. Let's see, if we take u to be that function, should we get back the remaining one as du? Okay, so let's set u to be 9x to the 4/3 plus 1 and differentiate. So du will be 9 times 4/3 x to the power 4/3 minus 1. So 4 minus 3, that's 1/3, and the plus 1 will go away, dx. And that's good, right? Because see, du have x to the 1/3 dx, which is the extra function that we have here. Okay, so let's solve for this portion. So what is x to the power 1/3 dx equals? Well, you could have cancelled the 9 and the 3. So it's 3 times 4, 12. That is du over 12. So we're going to use the u sub and we're going to use the du portion. So let's rewrite our integral. We have 1/3 integral. The square root becomes just a square root of u, and the x to the 1/3 times dx, replace that with du divided by 12. Okay, so again 1/12 is a constant, pull it outside. So we have 1 over 3 times 12, 36, integral u to the power 1/2 du. Okay, so let's continue. Look, now we can integrate easily. It's just a power rule of integral. Okay, so keep 1 over 36 as it is. And power rule, remember it's the power rule of integration, not differentiation. So we will have u to the power 1/2 plus 1 over 1/2 plus 1. And then, of course, we'll have plus c. But, you know, we can ignore that because we know that this will be a definite integral. We just need the antiderivative and plug in our limits later. Okay, one more step. Don't forget, we started with the variable x. We have to finish with x. So you have to rewrite u in the end. But let's figure out what these constants are going to be. So we have 1 over 36 and u to the power 1/2 plus 1, that's 3/2. Divided by 3/2. And then, so since you have a fraction 3/2 in the denominator, you can bring it in the numerator and you can flip it. So it will be 2/3 and 3 times 36. Okay. And you have u to the 3/2. Okay, cancel out 2 and 36. That's 18. So your final antiderivative is replace u by 9x to the 4/3 plus 1, the whole thing to the power 3/2 divided by 3 times 18. Okay, so that is our antiderivative. We are going to take that back here and then we will use the fundamental theorem, plug in the limits, and we will have our surface area. All right, so let's come back here. This is our definite integral, remember, and we have a 2 pi as a constant. Okay, and let's see, antiderivative is, let's bring out all the constants. So we have 3 times 18. And then this integral, antiderivative gave us 9x to the power 4/3 plus 1, whole thing to the power 3/2. And we have to plug in 1 and 8. Okay. See, we can cancel this out. The constant is pi over 27. And now plug in 8. So you get 9 times 8 to the power 4/3 plus 1 to the power 3/2 minus, you plug in 1. So 9 times 1 to the power 4/3 is just 1, so I'm not writing that, plus 1 to the power 3/2. So let us continue and simplify. The second term is easy. This is just 10 to the power 3/2. The first term, okay, so what is 8 to the power 4/3? Now consider, ignore the 4, consider what is 8 to the power 1/3, just 2. So this is 2 to the power 4, and that's 16. So this is 9 times 16 plus 1. power 3/2. All right, so you have the answer almost there. Just write down one more step. So pi over 27 times. Let's use a graphing utility to figure out what the values are. Okay, so 9 times 16 is 144 plus 1. So this is 145 to the power 3/2 minus 10 to the power 3/2. And if you want, this is to the power 3/2. So you can rewrite it as 145 square root 145, and the same with 10 to the power 3/2 is 10 square root 10. And if you want the answer in decimal, this is almost equal to, you can plug in all the numbers and you get about 199.48. So this is the surface area that we wanted to evaluate. Thank you.